Example 5. In an experiment on photoelectric effect, light of wavelength 400 nanometer is incident on ceridium plate at a rate of 5 watt. Assuming that on the average 1 out of every 10 power 6 photon is able to eject a photoelectron. Find the photocurrent in the circuit. So the wavelength of the light is given, which is 400 nanometer, and the power of the light is given, which is 5 watt, and out of 10 power 6 photons they are able to emit 1 electron. So we need to calculate photoelectric current. So since the wavelength of the light is given, which is 400 nanometers, means 4 into 10 power minus 7 meters, and also power of the light is given, which is 5 watt, means 5 joules per second. Therefore energy of the light is 5 joules, and every 10 power 6 photons will emit 1 electron. Therefore we need to calculate what will be the photocurrent or photocurrent in the circuit. So let us calculate first what is the amount of energy carried by one photon. So energy of one photon is equal to hc by lambda. So h is 6.6 into 10 power minus 34, c is 3 into 10 power 8, while lambda is 4 into 10 power minus 7. So what we get here, by simplifying it, we'll get 4.8 into 10 power minus 19 joules. So the energy of one photon is 4.8 into 10 power minus 19 joules. Therefore number of photons ejected in 1 second. So we need to calculate what is the total number of photons to carry 5 joules of energy, because one photon carries 4.8 into 10 power minus 19 joules. Then how many photons are required to carry 5 joules? Therefore total number of photons in 1 second is equal to 5 by 4.8 into 10 power minus 19. So approximately we'll get 10 power plus 19. So total number of photons required to carry 5 joules is 10 power 19 photons. Therefore, so out of every 10 power 6 photons, 1 electron is being emitted. Therefore the total number of electrons emitted is equal to total number of photons by 10 power 6. We will get 10 power 13 number of electrons will be emitted. Since we know number of electrons values, now I can calculate the charge of the total charge emitted. The total charge is equal to number of electrons emitted into charge of electron, which is 10 power 13 into 1.6 into 10 power minus 19 will give us 1.6 into 10 power minus 6 coulombs. So we need to calculate current. Current is equal to charge per time, per unit time. Time is 1 second. So 1.6 into 10 power minus 66 coulombs per 1 second. So we'll get 1.6 micro amperes.